So this reflection is in linear terms, right? Is in linear terms, and it's a ratio of voltages. It's V minus over V plus. We can go ahead and define that to be in dB, and that decibels, since it's a voltage ratio, which is V minus over V plus, you have to use 20 log 10 to convert it from linear to dB, to decibel. You have to use 20 log because it's a voltage ratio. And you can also view it as ratio of powers, for example, where you are using the square of the reflection coefficient as a factor of the input power that is getting reflected back. Square of the reflection voltage, because this guy is the voltage ratio, the square of theta represents the factor of the power that is getting reflected back. So you can imagine this to happen in this situation. You are having a Pin that is coming in. There is something that is accepted by the load, but a part of it is reflected back. How much is it reflected back? That depends on gamma square. So this reflected back is going to be, in fact, gamma square P in. And what's the accepted power? Of course, it's 1 minus gamma square. If gamma square is reflected back, 1 minus gamma square is going to be accepted. That's the factor of the input power that's going to be accepted. So the input, sometimes you can also write it as forward traveling power and backward traveling power. Reflected is the backward traveling power. P plus and P minus. You can also view it in terms of power, not just voltages. Now, if I have minus 10 dB, if this guy is minus 10 dB, my linear reflection coefficient is 0.33. You can go ahead and convert it from dB to linear scale, which corresponds to a VSWR.